Welcome to Angles of Elevation and Depression. I'm Mr. Pi, the math guy, and I'm going to be your host today. Let's take a look at this little diagram I got here. Now, the angles of elevation and depression are related. They come together in a pair. And the reason they do is if we look at this little diagram here, a hot air balloon, a little guy down here on the ground, and when they look at each other, people in the balloon and then the guy on the ground, they form this angle of depression and this angle of elevation. Now, if we look straight ahead as if to form two parallel lines, this line of sight forms a transversal crossing two parallel lines. So the angle of depression and the angle of elevation are congruent because of the alternate interior angles theorem. What we're going to take away from this lesson is that the angles of elevation and depression, really, we're going to be using the sine, cosine, tangent relationships, the trig relationships, to solve problems here. So let's take a look at angles of elevation and depression. In example 1, we're asked to describe angle 1 and angle 2 as they relate to the given situation. Well, this situation is similar to the hot air balloon and the people on the ground. Here we have an airplane and the top of a building, and if we project the line of sights of both of these so that they're parallel lines, we have a transversal, which is the line of sight, and angle 1 and angle 2 are the angles of depression and elevation. Specifically, angle 1 is the angle of depression. And the reason it's the angle of depression, it's the person looking down. And I kind of like to use beginning sounds there, depression and down, or it's the person or the object that's looking down from above. Angle 2 in this case, then, would be the angle of elevation. And the reason we call it the angle of elevation is because they have to look up. They have to elevate their head to look up. So in this situation where we have to describe angle 1 and angle 1 is the angle of depression, and angle 2 is the angle of elevation. In example 2, we have a problem-solving situation. And what I've been doing lately in my more recent video lessons is incorporating this idea of RISE, where we read, illustrate, solve, and explain the problem. So here, in the read, we're going to make sure when we read the problem, we take note of the question and any important information. A surveyor stands 200 feet from a building to measure its height with a 5-foot tall theodolite. The angle of elevation to the top of the building is 35 degrees. How tall is the building? I like to start in my read section with the question. How tall is the building? That's what we want to solve. How tall is the building? That's the question. Now here comes the important information. The surveyor stands 200 feet from the building, so he's 200 feet away from the building. And his measurement device is 5 foot tall. So that's important information for us to take over here to the illustrate. Now here, if we take a look at the illustrate, I already have a diagram here. If you're taking notes and you don't have this diagram, then you might want to pause the video so you can copy it down. What I have here is the surveyor, the building, his line of sight to the top of the building, his measurement device, and here I have two parallel lines. Now the reason I have them here is so you can understand that what we're working with here is an angle of elevation. This angle here is 35 degrees. What we're measuring is this distance from here up to here. That's what we're trying to solve for, in this case, x. We know the distance from the ground up is 5, and that's 5 feet because that's how big his measurement device is. So what we ultimately have to calculate is the distance from here to here, and then add 5 to that. What I didn't put in yet is this 200 feet because that's how far away he is from the building. And what you should see here is one of those trigonometry relationships where you know the angle, and here this is the side opposite the angle, and this is the side adjacent to the angle, so that would be the tangent. So in this case, the tangent of any angle, and I'm going to use a Greek letter here, this is pretty common, theta, and that's going to be equal to the side opposite over the side tangent. But not tangent, but adjacent. I said tangent and I meant to say adjacent there. That would be the side opposite over the side adjacent, not tangent, but adjacent. So we substitute in what we know. We know the measure of the angle, and that would be the tangent of 35 degrees. Now I'm going to caution you, when you do this on your calculator, you're going to want to make sure that your calculator is set in degrees, not radians. So then here, the side opposite is x, and the side adjacent is 200. So what we have to do here is we have to solve for x, and we simply multiply each side by 200. Because we have x divided by 200, we multiply each side by 200. From here, it really becomes a calculator problem. We're going to do two things here. On the left, I'm going to cancel out the 200s because they do divide out. And I'm going to switch sides, so the x is now on the left. And the x is going to be equal to 200 times the tangent of 35 degrees. And I believe we're going to cut away to a calculator sequence, and we are. So I'll see you when we get back from that. What we're looking at here is we're looking at how to do this calculation on a calculator, 200 times the tangent of 35 degrees. And in my class, I work with the TI-84 Plus. And simply, to do this, it's a pretty straightforward thing. Just want to make sure people are aware of how to do it. You'll type in 200 times, and then the tangent. Then here, one thing you're going to want to make sure of is that your calculator is in degrees. If you do that, you just press enter, and that gives you, you can see here, 140.04, so on. It doesn't really matter. We're going to round to the nearest foot anyway, so this would round to 100. So there you see how to do 200 times the tangent of 35 on a calculator, and that comes out to be approximately 140. And that would be feet. Now that's not our final answer. We'll get to that in our explain section. Over here in the explain section, we can keep it simple or we can really elaborate. I'm going to allow my work to explain most of what I've done here. So here's my explanation. From my setup, I saw a tangent relationship to find x. Then I added 140, the value of x, and 5 for a height of 145 feet, meaning that the height of the building is 145 feet. So this is using RISE, read, illustrate, solve, and explain, to solve a problem using the angle of elevation and trig ratios. Example 3, we have another problem-solving situation. An airplane flying at 3,500 feet above the ground begins a 2-degree descent to land at the airport. How many miles from the airport is the airplane when it starts its descent? So what we have here is we have an airplane coming in, it's flying, and at one point it starts to come down for a 2-degree descent, meaning the angle of depression is 2 degrees. Even though we don't really see an angle of depression, we can put an angle, a line of sight in here off of the airplane. And the angle of depression is going to be this angle right here, which means the angle of elevation is also going to be 2 degrees. And over here, we know it's 3,500 feet off the ground. So what this ultimately comes to be is we want to figure out how far away from the airport should this airplane start to make its descent. We're going to solve for x here. And again, we have a relationship with the trig functions. Angles of elevation and depression are applications of the trig functions, or one application of the many for trig functions. So here we have this angle here 2, and the side opposite and the side adjacent. So this is a tangent relationship. So the tangent of any angle theta is equal to the side opposite over the side adjacent. Now this is different from the last problem, and you'll see why when we substitute in. And for theta, we'll substitute in 2 degrees because that's the given angle. So the tangent of 2 degrees is equal to, now here's where the difference is. Now we know the side opposite, which is 3,500 degrees, or 3,500 feet. We have to solve for the side adjacent. So what we do here is we actually take 2 steps. We're going to do 2 steps at once. What we're going to do is we're going to multiply each side by x. And we're going to divide each side by the tangent of 2. And what happens here is that on the left-hand side, the tangents of 2 cancel, and on the right-hand side, the x's cancel. And what we end up with is what we need to use our calculator for. X is equal to, in this case, it's going to be 35 over the tangent of 2 degrees, or not 35, but 3,500 over the tangent of 2 degrees. When you plug that in your calculator, you just plug in 3,500 divided tangent 2 degrees, and that comes out to be approximately 100,227 feet. Now that doesn't work with our answer because our question asks for how many miles. So what we need to do is convert 100,227 feet into miles. And we do that with a simple conversion factor. That 1 mile contains 5,280 feet. When we do this, what this ultimately boils down to, I crossed out the miles when I shouldn't have. These miles should still be here. I cancel the feet. Ultimately, what this ends up being is 100,227 divided by 7,000 or 5,280 feet. When we do that division, it comes out to be approximately 19 miles. So for this airplane to land safely at the airport, it needs to start its descent at about 19 miles away from the airport.